Okay, our final multiple choice question, which of the following is the solution to this differential equation? So we're using terminology that we just spoke about in class, but ultimately we're asked to solve this differential equation, which means we want to find the original function. We want to find y. And so we have to do an antiderivative. And the antiderivative of sine is negative cosine. So what we end up with, our 2 will move down. Sine antiderives to negative cosine x plus c. And if we look at our 5 choices right away, we can eliminate a and b because we know we need a negative 2 cosine x. The question is, what is c? Well, when we plug in pi, we get 1. So 1 is equal to negative 2 times the cosine of pi plus c. Cosine of pi, doing a little bit of trig chart here, the cosine of pi is equal to negative 1. So we have 1 is equal to negative 2 times negative 1 plus c. Double negative means we got a positive, so 1 is equal to 2 plus c. We subtract 2 from both sides, and c is negative 1. And that means we want option E. All right, flipping over to our FRQ. We have a particle moving along the x-axis. Let's get the stem of the question onto the screen. There we go. We're given the acceleration of the particle as with time being positive. So we don't have to worry about any domain issues with t being equal to 0. We see that t is always greater than 0. And we're told what's going on with the position and with the velocity when t is equal to 1. So if they're telling us this, it's probably going to come in handy later on in the problem. And in fact, it comes up right away with part A. Write an equation for the velocity of the particle for any value of t. All right, well, that means we need the antiderivative of acceleration, which is 3 over t squared dt, which is going to be 3t to the negative 2 dt. So we can do our good old power rule here, and we can turn this into 3 and then t to the negative 1 over negative 1. Oops, there we go, plus c. So what do we have here? We have v of t. Let's simplify this a little bit. We have 3 divided by negative 1, so that's negative 3. And we have t is to the negative 1 power, so that's going to place it down in the denominator plus c. So there's our general solution, but we want the actual velocity, which means we have to solve for c. We see that when t is 1, velocity is 2. All right, so 2 is equal to negative 3 over 1 plus c. That's obviously negative 3, so we'll add 3 to both sides, and c is equal to 5. So to finalize our answer, v of t is going to be negative 3 over t plus 5, and we're ready to go on to part B. Let's get part B on the screen. Is the speed of the particle increasing or decreasing at time t equals 3? Give a reason for your answer. All right, so in order for speed to be increasing, the acceleration and the velocity have to have the same value, same sign rather, at whatever the time is. Our time is 3, so we're interested in a of 3, and we're interested in v of 3. All right, I'm going to scroll back up for a second. We see that a is 3 over t squared, so a of 3 will be equal to 3 over 3 squared, which is definitely positive. And v is right there, negative 3 over t plus 5. So v of 3 is going to be negative 3 over 3 plus 5. So that's negative 1 plus 5. So that's also positive. So both acceleration and velocity are positive at t equals 3, which means that the speed will be increasing. So we need to convey our thoughts here. So increasing because both a of 3 and v of 3 are positive. And there's multiple ways to write this, but that's the general point that you need to get across. All right, so moving up, now we need an equation for position. All right, well, position, x of t, that's going to be the antiderivative of v of t dt. So that's the antiderivative of negative 3 over t plus 5 dt. All right, so we're seeing a little natural log happening here. All right, we have negative 3 out front, and then we have 1 over t dt. And then 5 is just a nice constant, so we're looking at negative 3. This is going to become the natural log of the absolute value of t. 5 turns into 5t, and then we have our plus c at the end. Again, we're looking to solve for c. We have to go back up to the top of our problem. When we do so, we see that when t is 1, the position is 6. Okay, so 6 is equal to negative 3 times the natural log of 1 plus 5 times 1 plus c. The natural log of 1 is, yes, it's 0. So negative 6 is equal to 0 plus 5 plus c. So c plus 5 is 6, which means c must be 1. And therefore our position, x of t, final answer, will be negative 3 times the natural log of the absolute value of t. Although again, t is always positive, so technically we don't need the absolute value marks there because we're given our domain that t is positive. But look, there's no harm in having it there. Plus 5t plus 1. All right, and finally, find the position of the particle when t is equal to e. All right, so we want x evaluated at e. So that's negative 3 times the natural log of e plus 5 times e plus 1. We do not have to simplify, so we are done. However, if you chose to simplify, the natural log of e is 1. So we have negative 3 plus 5e plus 1. We can combine negative 3 plus 1 is negative 2. So technically it's 5e minus 2. Either one will work out for you. All right, so there's your study guide, and hopefully this helps out. If you have any further questions, please let me know